Welcome to this eLearn Security video training lesson. In this video, we will see how we can use the basic Wireshark features for capturing, filtering, and analyzing the traffic information we are able to intercept in a network. First, let us explain what Wireshark is. Wireshark is a network protocol analyzer. This means that it gives you the ability to investigate the traffic on an entire network when the promiscuous mode is available. Promiscuous mode is a network interface controller feature that allows us to capture and inspect the whole traffic that we receive on our interface. This differs from the default behavior where only the traffic addressed to your MAC address is accepted. This will allow us to see all the packets passing through the network along with all the information contained in them. It is important to know that if the network is protected, or if the network configuration has switches, you will not be able to capture any traffic that is not addressed to you, and you will have to mount attacks, such as ARP poisoning. As we've previously mentioned, with Wireshark, you have access to several packet information that pass through your network, such as the protocol header structure, destination and source address, port of the packet, flags enabled, and much more. The techniques we're going to see in this video will help us inspect the traffic in order to focus on specific packets, responses, and requests. Follow a full network connection or even capture all the traffic from specific addresses. What will help us to achieve these tasks are the Wireshark display filters. Display filters allow us to perform general packet filtering while intercepting the network traffic. For instance, we can specify to view only packets coming from a specific port or IP address, packets that use a specific protocol, and so on. Let's see some examples. First, we have to open a terminal and note our IP address and interface by calling the ifconfig command. Then, we run Wireshark and choose our capturing interface, which will capture all the network traffic in our local network. We choose ETH0 since it's our main interface. Make sure you choose the correct interface in order to capture packets with Wireshark. To produce some traffic to analyze, we will open our browser, and we will visit some web pages. Then we will ping the network gateway, and finally, attempt an SSH login. So let's first open our browser and navigate some pages such as Google and elsefoo.com. Now let us open a terminal and ping the gateway. This will generate a different traffic on the network. Right after the ping, let's try to establish an SSH connection to a machine in the network. It doesn't matter if we're able to access it or not. We just want to generate a different type of traffic. Now that we've generated some traffic, it's time to view what was captured with Wireshark. Before moving on, it's important to keep in mind that Wireshark uses different coloring rules to mark traffic with a specific protocol or type. You can see and edit the rules by clicking on View and then selecting Coloring Rules. As we can see here, depending on the protocol, we have different colors. For example, light green indicates a TCP connection, while light blue is mostly used to UDP requests. But it's not just that. If the packet has the RST flag set, it will be marked with a different color too, and the darker box usually indicates an error. Most common errors are transmission and retransmission errors. As you can imagine, the coloring rules will help us to easily understand the type of the response request. Notice that we can edit the specified colors, but this is out of the scope of this video. Now that we know the coloring scheme, we can go on with our tests. As we can see, all the requests and responses have been captured. We can now browse over the several options in order to filter our results. Filters can be applied to the current traffic by typing them in the input field in the upper left corner of Wireshark. For example, if we want to display all the traffic sent and received by a specific IP address, we can use ip.addr filter. This filter will list all the packets sent or received by the IP address specified. Notice that while typing the filter, if it is not correct, the background color changes to red, while if the filter is correct, the background turns green. We can also filter packets that have been sent from a specific address. To do this, we use the ip.src filter followed by the target IP, where src stands for source. When we need to specify a destination IP, we just have to use the ip.dst filter, where dst stands for destination. Another useful option is the ability to specify the protocol we would like to investigate. For example, we can choose to capture only ARP traffic. This can be done just by adding the ARP parameter. Other protocol filters examples are HTTP or ICMP. The latter, for example, will show the traffic sent during the ping tests run before. It's important to know that Wireshark allows us to combine these filters. As we can see, we only display traffic produced by HTTP or DNS. To combine even more of our requests, we can use the AND string or the AND symbol in order to specify more options. In this example, we are trying to capture HTTP or DNS traffic that, at the same time, is coming or is sent by the target IP address specified. A not equal operator is also available. For example, if we don't want to display HTTP packets from a specific IP address, we can add the != symbol followed by the IP address. Here's an example where we avoid capturing HTTP packets sent from IP 88.80.188.96. Wireshark also gives us the ability to apply filters during port scanning phases. For instance, while scanning or sending packets through the network, we may need to analyze only packets coming or being sent from specific ports. To do this, we have to specify the TCP or UDP.port, and then type the port we would like to capture the traffic from. Here, by specifying the SSH port, we can see the SSH request sent during our previous tests. Other useful filters are the TCP flag. Thanks to these filters, we can instruct Wireshark to display only the packets that have certain flags set. For example, we can add the tcp.flags.syn == 1 to capture all the packets that have the SYN flag enabled. If we tweak it a little bit, we can also check for the ACK flag too, while at the same time we can specify to display only packets that involve our LAN network. This is done by forcing Wireshark to look for packets inside the network subnet defined. Finally, we can also choose to see for specific words or strings contained in some TCP packets. To do this, we can apply the TCP contains followed by the string we would like to look for. Here we can display TCP packets that contain the word else foo. Among all its features, Wireshark also provides an option to follow a whole TCP or UDP stream that will be printed in the way that the application layer sees it. Let's see an example to make it clearer. Here we specify a filter in order to filter all the SSH packets in the network. As we can see, we've already collected some traffic from our previous SSH login attempt. In order to see the whole communication, we can right-click on one packet here and select Follow TCP Stream. Here, we can see the entire conversation between us and the server. Notice that the stream content is displayed in the same sequence as it appeared on the network. Moreover, the first part marked with a red color is the traffic sent from the client to the server, while the blue part is the response. We can also use our menu in order to specify which packets we want to see. Another option Wireshark offers is the ability to create a filter starting from an actual packet. For instance, when we see a packet and we don't know how to filter all the similar ones, we can right-click on the packet capture and choose the Apply as Filter option and then click Selected. On our example, we choose a random packet and use it to filter all the packets with the same destination IP address. As you can see, we now display only TCP packets filtered by a specific destination IP address. What makes Wireshark so special, though, is the information it provides about every packet we capture. By selecting one of the packets here, we can see all the information about it in the bottom panel. For better investigation of the packet, we can right-click and choose Show Packet in a new window. As you can see here, we have all the information regarding this specific packet, such as the source and destination machine, along with their IPs, the protocol that was used for communication, the destination and source ports used to communicate, the flags attached to the TCP packet, the information transmitted, and much more. Here we can learn everything about the packet sent and received. We can investigate more in order to find why errors occurred in the network, what data was transmitted, what flags were set, what was the packet structure, and more. This is the area where curiosity meets knowledge. We highly recommend you generate some traffic in your network, such as port scanning, host discovering, using applications that rely on several protocols, and more. Once you generate it, you should inspect it with Wireshark and apply the techniques seen in this video in order to broaden your knowledge. Keep in mind also that Wireshark will be used on future videos. Mastering it will be really useful for you. Thanks very much for joining us.